All right, ladies and gentlemen. So remembering that average atomic mass is the average between all the atomic masses, or really are adding up all the percentages of each atomic mass, and that's going to be your relative or overall atomic mass, which means that we have to look at all of them. So this one we have 63 and 65 for our mass numbers of copper. So let's write that down just so we know we're talking about copper 63 here, and we're talking about copper 65 over here. All right, and we know the percent abundance is 69.2% of the mass of copper 63, which is really 62.93 AMU, which means we're going to put 62.93 right here. And then 30.8% of our copper is going to be 65 for our copper isotope, or really 64.93 AMU. So we're going to put 64.93 right here. Now, when we multiply both of these, we're going to multiply their percentages. But remember, when we do percent multiplication, it's really that 69.2% divided by 100, because percents are always out of 100. And then this one's going to be 30.8 divided by 100. Now we can rewrite these with our division done. So we get 62.93 times 0.692 and 64.93 times 0.308. And remember that you can always do that division of 100 at the very end. I know some of you like to do it because that's how they taught you in the other video, but both ways work perfect. When we do this multiplication, we get 43.55 and we get 20 for our two masses. But remember, neither one of those are in between 63 and 65, and our average has to be in between those. So when we add those together, we end up with 63.55 AMU. And we know that has to be correct because most of our percentage is from copper 63. So it should be closer in average atomic mass or relative atomic mass to our copper 63, because that's where most of our percentage came from. Only a small portion came from 65, which means it should be closer to that 63 isotope. If you guys have any questions before your test, please let me know.